Chapter 5 States of Matter. In 5.1 Gas, students should be able to explain the assumptions of kinetic molecular theory of gases for an ideal gas. Next, students should be able to define gas law. There are three gas laws: Boyle's law, Charles' law, and Avogadro's law. Students also should be able to sketch and interpret the graph of the Boyle's law and Charles' law. Kinetic molecular theory of gases. There are 5 basic assumptions or postulates. First, the size of gas particles is extremely small compared with volume of container. So, volume of gas particles is negligible. Imagine only you in the middle of the field in a big stadium. You are such a tiny gas molecule in a larger container. The container as the stadium. So, this analogy shows gas particles are too small compared to the volume of container, as you are too small compared to the big stadium. Second, gas particles are in constant and random motion. They are frequently collide with one another and with the walls of container. So this animation shows the gas pressure is caused by gas molecules colliding container's walls. Third, collisions between gas particles are elastic. What is meant by the elastic? During the collisions, there is no kinetic energy loss, and total kinetic energy is constant. The elastic can be explained by this analogy. When the car bouncing off the truck and the truck is moving, so this is elastic collision. For inelastic collision, when the car hit the truck is stopped. So this is the example for the inelastic collision. Fourth, intermolecular forces between gas particles are negligible. This is because the gas particles are too small compared to its container, so the distance between the gas particles are too far apart, so the intermolecular forces between the gas particles are negligible. The last one, fifth, the average kinetic energy of the gas particles is directly proportional to the absolute temperature. From the animation picture, at the low temperature, the gas particle moving at the low speed, while at the high temperature, the gas particle moving at the high speed. Gas law. The physical behavior of gas can be described by 4 variables: pressure, volume, temperature, and number of mole of gas. Combination any these 4 variables will form Boyle's law, Charles' law, and Avogadro's law. Boyle's law. At constant temperature, the volume occupied by a fixed amount of gas is inversely proportional to the applied pressure. In mathematically, P inversely proportional to the V at constant T and N. include the constant, it becomes PV equal to constant. At the different condition, the formula is P1 V1 equal to the P2 V2, where P1 initial pressure, V1 initial volume, P2 final pressure, V2 final volume. To verify the Boyle's law, let's say we have a container with the volume 1 liter consists a gas molecule with the pressure 100 mm mercury. When the volume is decreased to 0.5 liter, the pressure of the gas molecules become 200 mm mercury. So what happened? When volume of container decrease, the average kinetic energy of the particles remain the same since the temperature is constant. Therefore, no change in speed in which the particles move. But collision increased because the container is smaller. The increase in the frequency of collisions with the wall of container lead to an increase in the pressure of the gas. So this verify the Boyle's law state that the volume of a fixed amount of gas is inversely proportional to the gas pressure at the constant temperature. These are graphs of the Boyle's law. There are three graphs of the Boyle's law. First, graph of the volume versus pressure. Volume is inversely proportional to the pressure. As the volume increases, pressure will decrease. Second graph is the graph of the volume versus 1 over P. It is a linear graph with a positive slope. As the volume increases, 1 over P will increase. And the last one, third graph of the PV versus V. It is constant because PV equal to the constant. Next, Charles' law. At constant pressure, the volume occupied by a fixed amount of gas is directly proportional to its absolute temperature in Kelvin. In mathematically, V directly proportional to the T at constant P and N. Include the constant, it becomes V over T equal to constant. At the different condition, the formula is V1 over T1 equal to the V2 over T2, where V1 initial volume, T1 initial temperature, V2 final volume, T2 final temperature, and the temperature must be in Kelvin. If given the temperature in degree C, at 273 or 273.15. Graph based on Charles' law. There are two graphs based on the Charles' law. The first one, graph of the volume versus temperature in Kelvin. The graph is linear. Volume increase as the temperature increase. Second graph is a graph of the volume versus temperature in degree C. The line shows how volume changes as the temperature changes. The dashed line extrapolated data to lower temperature for any amount of an ideal gas at any pressure. The volume theoretically zero at negative 273.15 degrees C. So this is absolute zero. Avogadro's law. At constant pressure and temperature, the volume of a gas is directly proportional to the number of mole of the gas present. In mathematically, V directly proportional to the N at constant P and T. Include the constant, it becomes V over N equal to constant. And at the different condition, the formula is V1 over N1 equal to the V2 over N2, where V1 initial volume, N1 initial number of mole, V2 final volume, N2 final number of mole. That's all. Thank you.